can start. So a very good afternoon, ladies and gentlemen. First of all, a very warm welcome to all of you from near and far to this workshop. This is a project founded by the Professional Service Advancement Support Scheme of the Hong Kong SAR government, and also supported by the Hong Kong Construction Association and the Royal Institution of Chartered Surveyors. My name is Jeffrey Shen. I'm the project leader. The project is entitled Improving and Exporting Hong Kong Industrialized Construction Services under the Belt and Road Initiative. This is a capacity building project. As you can see, the project aims to enhance the competitiveness of construction sectors in Hong Kong, facilitate integration of new technologies in industrialized construction, and encourage collaborations in construction services. Construction industrialization is also known as modular integrated construction in Hong Kong. We have several ongoing research projects in this area. In fact, we are still in the process of recruiting postdoctoral research fellows, research associates. If some of you are interested, please feel free to contact me. Next, please. Apart from myself, we also have Surveyor Thomas Jie, Chief Executive of the Hong Kong Construction Association, and also Dr. Justina Yung, Manager of the Belt and Road Liaison Unit of the Hong Kong Polytechnic University, as members of the project team. Okay, now I hand it over to the MC, Irfan, to introduce the workshop rundown. Irfan, back to you.
Thank you very much, sir. Today's workshop is divided into 4 parts. We'll start with the introduction to the invited speaker, followed by the presentation and the conduct of the workshop by the speaker, and the end question answer session, and finally I'll send a feedback poll or a survey. I'll request during this presentation to please keep your mic mute until the question answer session, where you can ask the question. Today's invited speaker is Mr. Ibrahim Yahaya WUNI. He is a doctoral researcher at the Hong Kong Polytechnic University and also an awardee of prestigious Hong Kong PhD fellowship scheme. He holds MS in Water and Environmental Management with distinction from the Hertford University in Scotland under the Commonwealth Shared Scholarship. Mr. WUNI also holds a BS Honours in Land Economy from the Kwame Nkrumah University of Science and Technology in Ghana. His primary research areas include construction management, sustainable construction, modular integrated construction, and real estate economics. His current research focuses on the measurement and the monetization of the intangible benefits of MICE projects. With this, I hand over the podium to Mr. Ibrahim Yahaya WUNI. Welcome, Mr. Ibrahim.
Thank you very much. Can you hear me?
Yes, I can hear you. Now you can share your presentation.
Okay. Can you see my slide?
Now, yes, we can see now.
Okay. So each time we hear about modular integrated, each time we hear about McDonald's, some things come to mind. For those of us who are very, conversant with McDonald's foods, when we hear the M Donald, what we begin to think about is that we think about consistency, we think about efficiency, we think about innovation. Today, my name is Ibrahim Yahaya WUNI, and I would like to actually expose you to some of the available technologies that we can use to McDonaldize modular building systems in Hong Kong. For now, I am focusing on Ghana, but the experiences are very applicable to all countries. My presentation is divided into 6 sections. And I'll start with the diagnosis of the global construction performance. All of us are very much aware that the dominant construction approach is the cast in situ construction approach. Now, we are all aware that this particular approach is not performing as we desire. If you consider the global construction industry, you have some common ill performances. The first one we always hear about is that we have time overrun. Projects actually go beyond their baseline schedules. We also have cost overrun. This is very pervasive. Projects are delivered beyond the baseline cost. We also have poor quality. We have high construction waste. We also have high greenhouse gas emissions. Construction safety is also another problem. And we have higher construction water footprint. If you look at it properly, there are some strategic problems that we have that require some assessment. The McKinsey Global Institute actually conducted this study, and they said that they found out that construction productivity only actually increased by 1% during the last 2 decades. That's 20 years. But when you compare that to the manufacturing industries, it is definitely a very bad performance. And the big question we have in anywhere, the construction industry we have in any part of the globe is, are we competitive enough? Can we meet the demands of the construction industry? Well, in order to answer these questions, there is this huge study, a very robust study that was done by McPharma, and it was done in the context of the UK. But there was a question and an answer at the same time that was posed, which is very relevant to our presentation or workshop today. He said that if we want to actually achieve higher performance of construction projects, then we have only 2 options. We either modernize or we die. Of course, we don't want to die, and we want to also modernize. So actually, there's an ongoing trend in the construction industry because the leaders of construction innovation, they are pursuing industrialized construction. Construction industrialization is becoming very pervasive now and is increasingly being adopted for many infrastructure and building projects. I am assuming that most of us do not know so much about industrialized construction, and I would like to make a brief introduction. Industrialized construction is a building construction system. It is almost the opposite of the traditional construction approach, because the traditional construction approach takes place on the job site, but this one, majority of the trade, the construction trade, actually happen in an off-site factory. So it is actually a building construction system that employs innovative technologies and processes. And these technologies include computer-aided design. We also have building information modeling. We have robotics and artificial intelligence. These ones are employed in industrialized construction to actually produce structural components in a controlled factory environment. And these particular components that are produced under a controlled environment, the quality is controlled and the waste are minimized, and they are then transported to the construction site, mostly in sections. As you can see, you can find a truck carrying a whole house, a whole room, or a whole building. Sometimes it's in sections, sometimes it's the whole volumetric component. These components are sent to the job site and then systematically assembled to generate industrialized building systems. But it is very interesting to understand that construction industrialization has been here for a very long time. In 2600 BC, the Egyptians had already constructed their pyramid, and they used large boulders. And these boulders were actually carved out away from the job site. In 1887, the Eiffel Tower in Paris was also constructed out of prefabricated building components. In 1968, the Roland Point apartment tower in East London collapsed. But this particular structure was constructed using prefabricated building components. In 2019, the Clement canopy was erected. Effectively, industrialized construction has been around for a very long time. But during the last 2 decades, it assumed a new dimension, and we have several industrialized construction techniques being implemented everywhere. Today, the focus is on modular building systems, because modular building systems are actually products of modular integrated construction. If you look at the reasons why we are moving towards modular construction in order to produce modular building systems, it is because of our desire to actually improve construction performance, the performance of these buildings. Some of the benefits that we have is that we have improved quality, because it's not in the factory, we can actually control quality, so we have improved quality. We have also reduced construction waste. We have improved labor productivity, because we have a cleaner environment in the factory. We have improved health and safety of workers. And when you go to the job site to assemble the modules, there's the reduced need to work from height, because the cranes are used to do that mostly. So we have improvement in the health and safety of construction workers. We also have reduced life cycle costs. We have reduced construction time. But the chief benefit of modular construction and the modular building systems is reduced construction time. Now, this is very important for the purposes of today's presentation. The question is whether construction industrialization is actually capable of addressing all the ill performances of the traditional construction approach. I think the answer is maybe yes, but the question is how. The reason why we have to ask this question is that we need to McDonaldize building, the construction of modular building systems, but we don't know how to do that. But McDonaldization have principles, and we have 4 principles of McDonaldization. The first principle is predictability. The second principle is calculability. The third one is efficiency, and the last one is control. Now, the benefit I mentioned earlier, they are geared towards actually improving performance, but these ones help us to actually have some bit of confidence in the realization of the benefit we expect from modular construction. If we can McDonaldize modular building systems, how can we do that? Now, the question here is, there's the need for us to fast track the extent to which we build so we can meet the demands of the construction industry. And that's why we need to McDonaldize modular building systems. But how do we do that? It's a very big question. And there's an answer to this. In order to McDonaldize, it means we have to make sure that we achieve the benefit of modular construction with predictability, with efficiency, with consistency, and we have also control. This particular workshop is arguing that if we need to McDonaldize modular building system, then we need to control it at source. And controlling at source is that we believe that most of the problems that we have, most of the ill performances that we have associated with the construction approach or the modular building systems is coming from the very beginning, the early decisions being made. And the reason is quite simple. In fact, for modular building systems, it is necessary for us to control it at source because there's always the need for us to make early commitment to the approach. Because if you do not make early commitment, you may not be able to ascertain the suitability of the design for the modular building systems. For now, not all these building designs are suitable for modular building systems. So there's the need for early consideration. We also understand that over 70 to 80% of performance issues start at the early stages, particularly at the planning and the design stage of every project. And we also know that project performances reflect design intentions. So controlling the source is the best way to is one of the best ways to actually McDonaldize modular building systems. But where do we start from? At the beginning, the topic that was sent to the participants, I intended to expose the beauty of modularity, modularization, and standardization. But there was a slight change in the topic because all these ones are part of they are within an umbrella of a major terminology that I would like to introduce. But for modularity, I would like to explain briefly what it means. Modularity is actually the extent to which you can produce building components. You can actually design, produce, and assemble them differently. That's the extent to which you can do this is referred to as modularity. And modularity is actually an engineering concept, and they always use it to actually measure the extent to which you can produce things differently by different manufacturers, and it can be assembled to actually realize the whole piece. Modularization is actually the process of building the components, a complex system from its component parts that have structural independence, but they have functional integration. The structural independence means you can actually manufacture them separately, and the functional integration is they have to integrate to actually generate the holistic function required of the project. Standardization is actually the extensive use of methods, approaches, and techniques where we have repetition, then we have reliability, then we also have evidence of successful application. So it means that when you standardize something, it's the best form of it. Now, these three terminologies or concepts, they are all engineering concepts. They are very much related, and they are at the starting point of this because they're actually being considered at the design stage of a modular building system. Because without modularity, you cannot have modularization. And if you cannot have modularization, you cannot also have standardization. But the question is, how can we actually draw on these three concepts to realize McDonaldization of modular building systems? Now, the thing is, we have to break a chain. And the chain is we have to move away from the way we design buildings and move to another innovative way of designing. And this design approach, which can help us to realize the full benefit of the three concepts towards McDonaldization of modular building systems, is design for excellence. Design for excellence is a very unique concept. And for most of us, we may have not heard about it, but today I will take you through design for excellence and explain to you the concepts and how we can use it to McDonaldize modular building systems. But there's a need for us to introduce the concept itself. Design for excellence is actually the application of rules, guidelines, and methodologies in order to create a product which has higher quality and also meets the requirements of the client. Actually, it involves a range of goal-specific design methods, because for design for excellence, the excellence part is a very unique component. So you are designing for something, so it means you are goal-specific. So it allows manufacturers to differentiate the project, the quality of it right from the very beginning, before the actual project, before the production even starts. So in order to actually explain why design for excellence is having a potential to help us McDonaldize modular building systems, is the need for us to differentiate between the traditional engineering design and design for excellence. The first difference is that as for traditional engineering design, it often addresses issues at the designs after the design phase. But for design for excellence, it starts addressing the issues that we might encounter at the production stage, transportation stage, or on-site assembly stage at the early design phase. So they anticipate the problem. So it adopts a proactive approach towards addressing design problems that may transcend into major problems at later stages or downstream sections of the modular building system supply chain. The traditional engineering design also uses several iterations of a product, but for design for excellence, it tries to get the design right by limiting the iterations that it makes in the design. The third one is the traditional one uses many tools, but the design for excellence actually selects a particular tool which is very efficient in achieving a particular design objective. The traditional one also considers functional requirements, but the design for excellence considers the life cycle requirements of the project. it is interesting to know that there are several objectives you can derive from the design, but in the engineering one, there's less collaboration between manufacturers, suppliers, and customers. But when it comes to design for excellence, there is the necessity, there's a requirement for this collaboration because there is diverse expertise required to deliver the expected design goal. Modular, the design for excellence actually employs what we refer to as concurrent engineering methodology. And this one, it allows parallel activities in the design stage to be conducted simultaneously. So different stages are done. It's not like the traditional engineering design where you have to complete one stage before you move to the next stage. It actually operates to prevent the problem at the early stages rather than solve it later. And what it does is that it has a beautiful way of controlling and regulating project performance at the early stages. Typically, what is very interesting about the design for excellence is the fact that it is purpose and goal driven. So it doesn't actually use an approach where we have coincidence. No, there's a target, and it actually employs strategies to get the product right at the early stages. There's a need for us to understand this because if we do not understand this, then the whole purpose of this design for excellence may be missed. So the collaboration approach actually takes place at the early stages of the project. And this is the design stage. Now, you've seen that design for excellence has been abbreviated as the DFX. Now the variable X there represents several design targets. And these targets are actually diverse, but their structure is very much simple. They are categorized into five components. Or the targets that we would be having, or the methods that represent the X, such as design for that, they are structured into 5 components. And for those who are into practice, it is useful to understand that the guideline category actually, it helps us. It tells us what are the procedures for us to follow in order to achieve the particular design goal. The checklists are actually the items we need to take into account when designing in order to achieve the design goal. The metrics are actually, they are quantitative parameters that are used to appraise the performance. It's used to appraise the performance of the design that we have produced. And the mathematical models are used to calibrate the performance quantitatively too. But the overall methods, actually, they are the methods themselves, and they have all these ones. And the goal is giving you the guidelines, the checklist, the metrics, and the mathematical models to design a product that meets the requirements of the client and also achieve project objectives. There are several methods of design for excellence, and these are the list of the most common ones. But I will not address all these ones. I would address the high impact ones in the context of modular building systems vis-a-vis McDonaldization of modular building systems, because the idea is we want to have efficiency, predictability, consistency, and control over the benefits we can derive from modular building systems. The first one is design for assembly. Design for assembly, what it does is it seeks to ensure that the design of the modules facilitates their assembly. So when you do this, the major aim is to achieve efficiency and ease in the assembly of the modules, but we also have reduced assembly time and the complexities because we already know and we have minimized all errors that may compromise the assembly at the early design stages. So it anticipates defects and correct errors in the assembly at the design stage. And so it allows us to, proactively identify potential reworks and save time. But one interesting thing, or one interesting consideration we need to know is that during design for assembly, we have two considerations. And the consideration is one of them is, are we going to use human beings to do the assembly of the assembly of the subcomponents in the factory, or we are going to automate that? And when we have the human beings, a major consideration is to be sure that we have accessibility to small spaces. We also have logical layering of the components, and we also have the ability to fit the components together. And the last one within the manual approach is mistake proofing. When we are using machines, we can be very sure that we can instruct and put algorithms for them to achieve perfection. But human beings can't do that. So the mistake proofing is an important component of every design. If you look at it properly, when you use your mobile phone and you have a battery in it, and you want to actually insert the battery into your mobile phone, remember that particular battery that you have, it's a component designed in the factory. And this component was designed in order to fit into that particular mobile phone to perform a stated function. But because they were very much aware that you're going to use manual assembly, they incorporated mistake proofing into the design of that particular battery, such that it can only enter in one way. And when you enter it that way, immediately you turn it on. If you entered in the wrong way and you turn it on, it is not going to, the phone is not going to turn on. So the mistake proofing allows you to only have one way of actually assembling that particular component. And so if you make a mistake, obviously it's not going to fit, and you keep trying until you can fit it. But where we have automation, the consideration is that you have to know the part orientation, the techniques for the segmentation among the different parts, and the spacing, because these ones are very critical for the automation, because machines are doing this, and if you do not arrange this, the geometry of each particular module may not be fit properly. Like I explained earlier, the mistake proofing is essentially an idea that you make sure that there's only one way to assemble the project. Design for manufacture is the second one. First one is design for assembly. Second one is design for manufacture. As for design for manufacture, what it does is that it seeks to actually reduce manufacturing problems at the early design stages. Before the production even starts, we have addressed the problems. So we have proactively avoided the mistakes that we may have. One thing we must understand here is that for modular building systems, for those who are not very much aware, if you have some bit of standardization or you have a large project, for instance, you have a student hostel, when you're manufacturing the modules, if there is an error in the design of one module, remember the rooms are very much similar. So one design could be used for mass production of the modules for each room. So if there is an error in one particular error in the design, and it is not identified at the design stage, and it is carried on into the production, it is going to lead to systemic problem. A systemic problem because it is going to be replicated across all the modules during the mass production stages. But design for manufacture, this principle within the design for excellence seeks to mitigate this problem. And by mitigating it, we can control the benefit we would get towards McDonaldization of modular building systems. So design for manufacture actually seeks to ensure that when we are manufacturing the components, it is not beyond the capacity of the manufacturer or the supplier. Because oftentimes there is a requirement for the involvement of a manufacturer and a supplier at the design stage. And the reason is very much simple. Because they have expertise in the production, they are able to incorporate some of the manufacturing problems into the design of the modules so that we can actually address those challenges at the design stage before moving to the production. So the design for manufacture helps to ensure that we meet the capability of the manufacturer or the supplier at the design stage. So by doing this, what it does is actually select the cost-effective raw materials and attempt to minimize the complexity in the manufacturing during the design stage. Because if you do not select the appropriate materials or cost-effective materials, maybe the benefit of reducing the cost would not be achieved. And if you do not reduce the complexity in the manufacturing, then you may not be having efficiency in the assembly. There's a third concept, which is called design for manufacture and assembly. This is also referred to as assembled design. Some researchers and some practitioners refer to it as assembled design. But when you look at it, you can tell that design for manufacture it's a compound design terminology. It actually employs both the principles of design for manufacture and design for assembly at the design stage. So for this one, we can say that it draws on the advantages and the benefits of each of them, design for manufacture and design for assembly, at the design stage. But it is typically a unique approach. You can either have the unique ones as a design for assembly, design for manufacture, or you can have this one as a separate design for excellence method. So it is actually an engineering philosophy and design methodology which focuses on actually reducing the time to market and the total cost of production. Now, the idea is very much simple. If you are able to minimize all errors, all manufacturing and assembly errors, you can produce the modular building system early and you can penetrate the market early. You reduce construction time. So because it employs the two, it actually simplifies design of the product to ease the manufacture and actually improve the efficiency of its assembly. So in order to show some demonstrations of how this is done, I'm not a designer myself, but I have some basic knowledge of the design for manufacture and assembly methodology. It usually starts with a concept design. I don't know if you can see this. It starts with a concept design. Then at that stage, you move next and employ the design for assembly. Of course, we have tools for this. One popular tool is the Boothroyd design DFMA tool. It is used in the engineering field. In fact, it's also used in the construction field too. But there are other advanced techniques that you may want to learn about, and you can check that one out later. After the concept design, then you move straight into the design for assembly. At this particular stage, there are always some suggestions for simplification of the product structure. And if you do not have some suggestions and you believe that's okay, then you can move ahead and select the materials and processes. But if you have issues, if we have issues with the design for assembly, then we can go back and correct the concept design and come back to this. When selecting the materials too, there's always the need for us to select cost-effective materials and sustainable materials and processes. So if we feel that the materials we have selected to are not appropriate to, or they are not sufficient, we can take the suggestions and go back to the concept design, change the concept design, come back to design for assembly, and move to the material selection. After that, we pick the best design concept, which has incorporated the design for assembly. After that, we move straight and incorporate the design for manufacture. It is interesting to find out that the thing is designed for manufacture and assembly, but we have assembly first before the manufacture. The reason is actually very much simple, because this design for excellence takes a future approach. It takes like a proactive approach. So it tries to address the errors that we may have in the assembly section, have that in mind, incorporating the design before even bringing the manufacture. In that way, you have a very integrated way of looking at the assembly and the manufacture to address the challenges of each using the best of resources. Now, at the design for manufacture, you try to actually minimize cost. And so there's the need, at this particular stage, the detailed design stage is actually a crucial component, and time is spent at that stage to actually know the techniques to employ to actually reduce the cost that is required to achieve a design goal. Now, after that, we have a prototype and we have a production of the module. Another concept is design for cost. Now, whether you are using a traditional engineering design or design for excellence, we have to understand that over 75 to 85% of the cost can actually be determined at the design stage. The rest of the cost, that is for modular construction, the rest of the cost actually start coming during the production towards that end to the assembly of the components. So design for cost is tailored towards minimizing cost. This is why design for excellence is considered a purpose, objective-driven approach to design. So there's always a target. So design for cost, so you design specifically to reduce the cost. So what it does is that since the cost is actually a function of many items, a function of many processes and materials and resources, the design for cost actually combines several of the techniques. And the reason is very much simple. If we can easily assemble a module which is logistically efficient, and we can manufacture it with ease, and we can service it easily, then definitely we can reduce costs. So because of this, because cost is influenced by several components, the design for cost actually combines several design principles to lower the production cost. So what the design team does at this particular stage is they conduct value analysis, function analysis, and they also actually analyze suppliers and the materials they are going to select in order to reduce the cost. The next most important method is design for quality. This one is very interesting, and I particularly like this one because what it does is it employs tools, several tools, and it includes both computational and experimental analysis. And the idea is that we try to resolve and avoid some of the costly defects that we may have at the design stage. Now, there's a big problem we have in the construction industry. For every project, we have reworks. And some studies have estimated that cost of reworks alone can be up to 10% of the contract sum. That's a huge sum, 10%. So design for quality is tailored towards actually even avoiding those defects at the design stage. Of course, there may be some minimal errors, but it attempts to do that. So it proactively anticipates, resolve, and minimize all project quality risk at the design stage. Now, one useful thing is that for modular construction, modular building systems, we always have dimensional and geometric variabilities. Because when you are stacking the modules together, we have geometric and dimensional tolerances that you need to consider. And these tolerances, if the tolerance that you have specified is beyond the allowable tolerance, then they may not fit in well. And if they do not fit in well and you do not actually identify it early, what that means is that you may have to, you produce the building and in the end, there are quality problems, or you have to rectify it with expensive, it is going to be costly to rectify it and correct those reworks in modular construction. And because if you stack them and they are wrong, and if even they're inappropriate or incorrect, and it's because of dimensions, if those dimensions are actually related to the design, then you need to go back to the very early stage design, redesign the module, manufacture it, and transport it to the site and assemble it again. This is a huge sum of money. But we are also aware that as for intra and inter-trade related defects are very common. You know, within a module, if we are assembling a room and we have the walls and all those ones, the facades being assembled, at that particular stage within the building, we even have inter and intra. Within intra and inter related, those related defects are also there before they even go to the site. So for design for quality, we try to address those issues first And if we address those issues, we are very much sure that we can get quality, we can improve the quality of the final product we are going to produce. This is towards McDonaldization because there's predictability in the quality from the design. So how do we achieve this? So we constantly review each stage of the design to ensure that it is devoid of all errors. So actually design for quality may constitute a component of design for assembly, but it is a unique design component on itself, and you may want to check it out. The primary benefit of this particular technique that I see is the fact that it addresses dimensional and geometric variability problems at the design stage. This is very powerful. The seat one is designed for sustainability. Sustainability is a buzzword everywhere, but we should know that if we want to attain a sustainable or a high performance modular building system, then we must attain that at the design stage. Because definitely the building is going to be a realistic manifestation of the design intentions. And so if you need a sustainable building, then you need to have sustainable design. And if we are targeting sustainability, improve sustainability or improve environmental impact, then we need to make sure that we design the buildings to be sustainable. Of course, we can select sustainable materials, we can incorporate sustainable design principles. Hong Kong has a very useful technique and it demonstrates design for sustainability very well. So the Hong Kong government realized that there was so much waste. Of course, that's its environmental sustainability dimension of the triple bottom line. In order to address the waste, the government proposed that the waste should be addressed at source. And addressing the waste at source means that addressing it even before it comes. So we're not managing it, we're addressing it. So they implemented prefabrication, and the widespread use of prefabrication actually reduces construction waste footprint. So design for sustainability is a very powerful concept that can be employed at the early stages to realize sustainability of the project. So it is a holistic approach, and what it does is that it integrates and addresses sustainability dimensions at the early stages of the project. So every single sustainability requirement of the project is incorporated into the design. And you are sure that at the end of the design, because you've already tested, you've already done everything, and you know that, okay, in fact, there's always a trial assembly or even mock-up test in the factory, you will know very well that the building you are coming to produce is going to be sustainable. Indeed, this is one of the most significant drivers of modular construction or all the industrialized construction techniques, because there is the increasing need for the built environment to adopt sustainable building practices towards contributing to the sustainable development discourse. And modular systems, modular construction, industrialized construction are actually doing a very good job towards contributing to this course. So effectively, design for sustainability it's complicated, but in its simplest form, what it means is that you incorporate the environmental, the economic, and social consideration that you want, the social requirements. For instance, if you want to have improved safety, then you incorporate that into the design early. If you want to have reduced carbon emissions, then you incorporate that, you select the material well to reduce carbon emission. If we have the cost, and all other components of sustainability, you incorporate into the design at the early stages, even before the production. It may be argued that this approach is very much the same as eco-design. No, eco-design is different from design for sustainability. Actually, in my opinion, design for sustainability is a bigger concept within which eco-design is situated. Because eco-design, the focus of eco-design, of course, it also adopts a life cycle approach, but it always emphasizes environmental performance. But sustainability goes beyond that to incorporate economic and social dimensions. In fact, there's even a fourth leg of sustainability, political sustainability. It also incorporates that as well. The seventh method is design for supply chain. We all understand that the supply chain of modular building systems currently is fragmented. very fragmented. And this fragmentation require extensive coordination during the production process, because some people argue, some researchers and practitioners argue that the supply chain starts from the production of the modules, transportation, and even excludes the on-site assembly. But actually, in the context of design for excellence, the supply chain starts from the design. It starts from design because if you want to improve the supply chain and avoid supply chain disruptions and disturbances, then you start addressing those issues at the design stage. In fact, the supply chain in itself is actually a reflection of the supply chain intentions incorporated into the design. So supply chain performance can be improved at the design stage. Design for supply chain is also referred to as design for logistics. So what design for supply chain is? So someone is actually having an audio on. So design for supply chain is what we, in order to design for supply chain, we actually have the appropriate selection of the materials, the sourcing, the supply of the materials, and all the components of the supply chain at the design stage. We actually incorporate all those supply chain decisions and processes at the design stage. So it seeks to improve the supply chain performance, starting from the design to the transportation of the modules through to on-site assembly. So this is a very useful concept that you may want to actually learn if you are in the industry, because this is the last one I'm talking about regarding the methods for design for supply chain. But there are several other methods. If you are an industry practitioner or you are interested in modular construction or industrialized construction, it would be very, very useful for you to have some basic knowledge of design for excellence, because design for excellence is one of the paramount tools. In fact, I think it's a very strategic path that we can adopt to McDonaldize modular construction, modular building systems, and industrialized construction. Now, I will take us through the design for excellence process. There's a process simplified for the purposes of us for us to have a practical feel of how this works. So what it does is that we have a product requirement, and the requirement is specified by the client, and the architecture is given. Then we have high-level design. After high-level design, we move to physical layout. We have the prototype, we have the validation, and the production. Of course, it ends here. But if you have issues, then you can go back to the requirement and go through the process again. Now, it adopts a cyclical approach, because at the design stage, the idea is that to the best of the knowledge of the design team, they have to address all issues. So even if we reach to the production of the design itself, and we realize that there are errors, then we have to go back to the requirement and start modifying the process until we are very sure that the final design that we produce would deliver the design target or the design objective. So when we are starting the design for excellence, we design first, then we verify, we review what we've done already, then we produce the design, then we test the design. So after this, when we test the design, then we test it for performance, we test it for testability, because we also design for testability too. Then we test it for manufacturability. We test it for serviceability, we test it for cost effectiveness, and we also test it for quality. So the construction industry is actually moving towards design for excellence, because it is a strategic tool. It's been used in the manufacturing or the engineering industries for a very long time. And it's been used to leverage standardization, leverage higher productivity in the manufacturing fields. But we do not have widespread use of this one in the construction industry. Particularly, if you look at modular building system, now we have like design for manufacturing assembly. When you talk about modular construction without this, they say you don't know what you're doing. So it means that the emphasis now is design for manufacturing assembly. but there are other components of design for excellence that can give us the best of modular construction. And I think we can McDonaldize modular construction with design for excellence. So I'll take you through some of the benefits. The benefits are many. For me, I think that if you can reduce construction time, reduce the time because you have addressed all the errors. Sometimes it's because of errors, reworks that actually delays the project. You have to correct all those ones. You have to address these challenges, engineering challenges, assembly challenges. But if you can anticipate all those ones, I think it's the fastest path to market leadership, because if you're able to deliver the products timely without errors, then certainly you will be having a high market share, because you reduce the time to the market and always you deliver on time. We also have improved quality of the projects, and we have because of early prevention of the defects. So if you have early prevention, you deliver on time, certainly you are improving client satisfaction. So the benefits are many, ranging from the enhanced client satisfaction to the last one, which is reduced engineering resources commitment. These benefits are diverse, and they actually serve as the drivers for design for excellence in many fields. Now, one useful thing here is that because design for excellence is a cyclical approach, and is you can always improve it by reviewing it, it supports continuous improvement, and is considered as a lean design process. Lean design process. The lean design process, it's actually two components. Sometimes reducing redundant activities is one part, and another part is actually reducing waste in material and other components. So design for excellence delivers several benefits, and I strongly believe that if the construction industry pursues the design for excellence to the optimal level, then we can McDonaldize modular building systems. But there are some common mistakes in design for excellence that I would like to highlight. And the first mistake is that if you do not have collaboration and review of the design throughout the stages, the requirement, the conceptual design, the detailed design, and the production or the validation or the evaluation stage, those stages of the design, if you do not have collaboration early, then you cannot achieve the full benefit of design for excellence. Collaboration is required, and you need to review each of the requirements along each of the stages. If you also have poor understanding of the supply capabilities and limitations, you may not be able to deliver the best benefits of design for excellence, because the design is going to be used to produce the modules, and you do not know the capabilities of the supplier or the limitations they have. Then you design it in your own way, like your own wish design, without considering the realities. Certainly, you will not be able to deliver the full benefits of design for excellence. The third and the last common mistake is not considering the expectations of the client, because it is purpose-driven, and every client has what they require of a project. Sometimes they want you, they may be ready to commit a lot of resources for you to deliver the project on time, or they may be ready to commit a lot of resources for you to meet a high quality. And so if you do not actually understand and incorporate the expectations of the client into the design, then the full benefit of design for excellence may not be realized. But there are some best practices in design for excellence that I would like to highlight. One single most useful best practice is collaboration. And the collaboration is that you have to involve all the key members or the key players of the design team. You have the designer, the structural engineer, the architect, the supplier, the manufacturer. In fact, you involve the local contractor too. In fact, you have to involve the contractor, because he would be playing the role when they are assembling. So if you design a project and you do not involve the contractor, and you do not involve the supplier and the manufacturer, that I consider as the production team. This production team and the on-site team is the contractor, you would have what we refer to as over-the-wall syndrome. And over-the-wall syndrome is a common concept in building construction, where you design a project and those who are supposed to deliver a project are not privy to the design. So the engineering specification, the design, they may not understand it properly. Of course, they have knowledge and they are expected to know, but they may not be capable or they may not have enough experience and expertise to deliver it to the best of the design intentions. So involving these designers, the designers, suppliers, manufacturers, and local contractor at the early stage means that you would be able to have their input incorporated into the design, and they would also be very much abreast of the design specifications before the design even reaches them at downstream supply chain, because they are actually downstream. Starting with the design, after that, they move to the production, and the logistic team takes it in that order. So involving all these people at the early stages, it's a best practice in design for excellence. Of course, it may be difficult, but the benefits are worth it. The second most important best practice is that you need to review the key stages throughout the design. And so constantly you need feedback to improve. Now, this may be seen as very costly, maybe like time consuming, but the time you expend here, it is going to be commensurate, because you would even have more savings, because you would have addressed some of the critical challenges that always cause project delays at the design stage. So these two are some of the commonly noted best practices in design for excellence. Now, the topic for the seminar is McDonaldization of Modular Building Systems in Ghana. And I'm trying to expose the beauty of modularity, modularization, and standardization. And I've changed it to design for excellence. Now I'm targeting Ghana because, not because I come from Ghana, but because we're trying to export the best practices from Hong Kong to other countries. And so we are diagnosing the Ghanaian situation in order to draw lessons and learn from the Hong Kong situation, from the Hong Kong best practices and those of the Singapore and Malaysia. So there's the need for us to now diagnose the Ghanaian construction industry. Of course, the construction industry is very diverse, and I will not be able to diagnose it comprehensively. And I'll be targeting housing because you would understand that the housing situation in Ghana is a very big problem. It's a big problem because we have both economic and physical deficit. Even if they supply the houses, in fact, there are already houses in the market for sale, but the people do not have enough money to buy those houses. They also have like a very huge housing backlog, but because they don't have the money, they cannot actually buy those houses or even rent. So McDonaldization modular building system in Ghana, the idea is that we have to produce houses very quick, produce them at affordable prices, and produce them with high quality to meet like livable standards. So I would like to introduce Ghana a bit, and I will be doing this with very much passion because this is my country. Ghana is in West Africa. This is the map of Africa. And Ghana is very tiny over there, the red shape. This looks like a bag. The map of Ghana looks like a bag. But this is it, and we now currently have 16 regions. In other domains, it may be considered as provinces or councils, but in Ghana, we consider them as regions. We have 16 of them. The one that is marked there below is Greater Accra, and it's the capital city of the country. I'm going to give you a brief profile of it shortly. The official name of Ghana is the Republic of Ghana, and we are an independent country. We practice democracy. We renew our leadership every 4 years, and we have universal adult suffrage. We vote. Everyone can vote if you're more than 18 years. The capital city is Accra. It's located in West Africa. Our population is now a little over 31 million.
That's a very big one for us because we're not really that rich. And our official language is English. We have many languages, local languages, but our official language is English. And we have the Ghanaian cedi as our currency. We also have some major infrastructure projects that we can boast of. Most of them are still under construction. Now, I'd like to highlight them. These are some of them. We have the Accra Marine Project. We have the Tete Kwashi Cocoa Museum. We have the Signature Project. All these ones are, some major infrastructure projects. We have others that are already there, like some powerful interchange that you would like to see. For a developing country like Ghana, this is very significant. So if you ever come to Ghana, you like to visit, please don't forget to go to one of these places. Even if it is not completed, you would have a very good scenery view for yourself. And this is Ghana, and I would definitely encourage you to invest in Ghana. Now is a very good time to diagnose the housing deficit in Ghana and to make a case for the McDonaldization of modular building systems and to describe how design for excellence have been used in Ghana as a starting point, of course, at the pilot stage. So the Ghanaian housing deficit is very dangerous because as of 2010, the backlog was around 2 million units. And I think it was not even counted properly. Maybe in some of the villages, they did not count. I'm sure it's more than that. That's 2010. And there have not been very significant production of housing. Those that they have been produced, they are produced sometimes and they are branded as affordable, but they are beyond the financial reach of the low to middle income group, which they are the majority of the population. So with this one, the United Nations in 2017 actually estimated that Ghana needed 5.7 million rooms by 2020, this year, to actually meet the housing need because of the rapid growing shortfall. So this 5.7 million units starting from 2011 meant that we were supposed to be producing 3.8 new rooms per every minute of each working day for 10 good years. This has not been done. It is not possible because the dominant approach in Ghana is the traditional construction approach, and it cannot give us this speed, it cannot give us this predictability, it cannot give us all the things that we require to produce houses in minutes. That is not possible. So the Ghanaian housing problem is complicated. It's complicated because at the moment, the only way we can address the housing deficit is to be able to employ a technique which is capable of giving us speed, giving us mass, giving us quality, and also giving us affordability. And I believe one of the ways to do that is modular building systems. So McDonaldization of modular building systems has been identified as a priority area. Although it has not gained much popularity at the national level, some international companies, including China, those in China have already entered the market and started piloting some projects. But this particular workshop is within the context of the Belt and Road. So there's the need to describe the link between the Belt and Road and Ghana and that of our housing deficit. Now, the Belt and Road span across several places, but if you look at the red line, you have some of the lines actually reaching Africa in Kenya, Djibouti, and some other parts of Africa. Now, if you look at Ghana, Ghana is somewhere around that place, and definitely we are not part of the Belt and Road. But since the network reaches Africa, within the continent, transporting the modular components would not be a problem, because moving from China or moving from any other parts or UK elsewhere where we have the components being produced, if you have a very efficient transport network, then infrastructure network that can facilitate transportation, then definitely you would improve the transportation of the components to Ghana. It should actually be noted that in Ghana, we don't produce components. In fact, in Hong Kong, we don't even produce components within the interior city. So most countries are relying on China and Malaysia and other countries to get their components. Ghana is also relying on China based on the few components that we have. So I'm trying to demonstrate a case study where Design for Excellence was implemented in Ghana, and it was used to deliver a modular building system, but it wasn't directly a house because the houses haven't started yet, but they started that particular component. Now, that particular project has a title. It is located in Accra, the capital city of the country, and it's actually, the client was Hilton Inc., and what they did was that they wanted to construct a modular hotel in Ghana. And this particular hotel is the first Africa's modular built hotel in the continent. This particular hotel located in Accra. It is a 280 guest room, and the manufacturer was China International Marine Containers. They actually, they brought the containers from China for the delivery of these, the buildings in the 280 guest room. Now, this particular project is a signature project because the performance is very impressive. And if you see it, you would really like to go in there. Actually, it's a guest room. And if you ever come to Ghana and you want a fancy place, I would encourage you to go there, but you should be prepared to pay a little higher. So there are some performance metrics that are very interesting because they employ design for excellence in that. Because those of us who know Hilton Inc., we know they are a multinational company, and they deliver tourism. They are into tourism and issues like this. So they are incorporating some of the best practices around the world in the delivery of their hotels because they want to give clients the best of their services. So when they completed the project was delivered within schedule. It was also delivered within budget. There was zero waste. There was zero fatalities. In fact, the client was satisfied because they were part of the construction and there were very minimal defects. Of course, when you put all these things together and you can be guaranteed that you will get these, definitely you are headed towards realizing the benefit of modular building systems. So within schedule means that we have reduced construction time or we meet the time, which is very impressive. And the budget, we're talking about cost here, which is a very big problem. And waste is the waste footprint. If we reduce that and its associated cost, there will be savings. Zero fatalities means that we improve the health and safety of the workers. Client satisfaction is massive. And very minimal defects means that the quality of the building, it's very impressive. Now, this is the end of my presentation, but I would like to give you some takeaways. The takeaways is that modular building systems can improve project performance. That's very true. And it is no longer esoteric. It is not actually peculiar to some few professionals. There are a number of exemplar projects that demonstrate that modular building systems can actually improve project performance. And when you add design for excellence to it, then you are going to deliver the best of it. Well, I also want you to take away that McDonaldization of modular building systems is possible. We can deliver those benefits like the quality, whatever, the productivity, all of them with predictability, efficiency, consistency, and control if we employ design for excellence. And I also want to argue that design for excellence is the most strategic part to improve performance of modular construction and modular building systems. I would encourage you to take a look at modular construction and design for excellence because these ones are the future of modular construction. Well, that's the end of it. And my name is still Ibrahim Yahaya WUNI. It hasn't changed. I'm a PhD candidate, and I would encourage you to collaborate where you can, like my professor said, the one who introduced you is my professor, he's my supervisor. Like he said, there are some postdoc and research associate positions. If you want to work with us and you have the qualification, you may want to file in your application. So you can collaborate with me, collaborate with my professor. I particularly on the project performance, that's what I'm telling. I am interested in project performance, industrialized construction implementation, best practices. That is what I like. Sustainable construction, and many others. So if you have an idea you want to talk about, you want to collaborate, I'm more than happy to collaborate. Thank you very much. Thank you for listening.
Thank you very much, Ibrahim. It was really very comprehensive and a very nice presentation. I hope the audience has actually liked it. If now moving towards the question and answer session. So Ibrahim, you can please open the chat box. You can see one of the question is already there. I also request the participants, if they have any question, they can write, or if they want, they can even ask by opening their mic. So yes, Ibrahim, can you see the question in the chat box?
I've yet to do that. Give me a minute. Okay. I just opened my chat box. I'm loading. Okay. Oh, good. Oh, good. So I think someone is asked. I can only see an email, but it's the person student. He said, "Is the concept of design for excellence I'm not sure this is really correct. To be applicable on all sorts of projects, or is dependent upon the magnitude?" Okay, thank you very much. That's a very good question. I would like to say that design for excellence may be a little costly, and for very tiny projects, you may not have many problems. And so if you want to employ that, you may have higher cost, because it's you have to employ computer-aided designs and all lot of techniques. For small projects, it may not be recommended cost-wise, but if you want to guarantee quality, it is useful for all types of projects. But now we all understand that if you have a project, you want to deliver the project on time, within budget, and then you have very useful quality. I mean, like very desired quality. I think it's useful for all, but it's very much useful for higher projects like the one in Hong Kong, with so many buildings, so many rooms for one single project. You may want to use design for excellence. I think another person has asked the question again. Basically,
it's the same one. So if anybody wants, you can write the question, so it can be read. Meanwhile, I have a question, Mr. Ibrahim, that from your presentation, you mentioned that Ghana is a middle income country, what I suppose. So considering the cost of the prefabricated construction, and what can you say about the affordability of this type of construction in Ghana? A better quality and this type of construction, what I think so, it will be little unaffordable to the people, to the public. So what do you think?
Well, in fact, I always wanted an opportunity to explain this concept to anyone interested in modular construction and having issues. First of all, let me be very passionate about this. At the current stage of the learning curve, modular construction, prefabricated construction, they're all expensive, especially in developing countries. In Hong Kong, to be precise, and even in Singapore, they try to sacrifice cost for time. So by doing that, there's so much material being used, and that's a lot of cost. But we need to understand that there's no future in the traditional construction approach. There's no future in that, because the way it is, we have declining workforce. We also have increasing cost overruns and all quality problems. In fact, it's not even futuristic. So modular construction, prefabricated construction, they are ideal. But the good news is that it is at the early stages. Of course, it's been around for some time and it's rejuvenated. But I want you to know that when we have best practices, modular construction or prefabricated construction, when we reach the highest stage of the learning curve, it is going to deliver projects far cheaper, of higher quality than all the traditional projects we have. Of course, I am very optimistic about this, because if you look at it, we have no option than to go for modular or prefabricated construction. It's not, we should not radically pick it, but the step-by-step that is being pursued in many countries, I think is very good. It's okay.
Thank you, Ibrahim. Yes, any question? We still have some time. the speaker can answer your queries or any questions, or if you have any comments, you can even ask your add your comments to the comment box in the chat box. Okay, I think if anybody still have some question, the email address of the speaker was displayed. Can you, Ibrahim, display your email address, the last slide?
Okay, I'll do that just now.
So here you have also some questions coming up, Ibrahim.
Yeah, just a moment. I'm having trouble trying to go back.
Okay, no problem. I'll display here. Can you read the question and reply to it?
Oh no, I think I can get the questions, but I wanted to display my email account. Okay, so there's a new question.
Yes.
Okay, let me take a look. Okay, I'm opening. My computer's a little bit slow. Which one is that?
That is, thank you for the presentation. I just read for you. May I ask, among all the presentation of the DFX, when applying them into exact projects, say your introduction of Hilton Garden Inn, is there any weighing or priority consideration? Some of them, I don't know whether you have understood or not. If you can read this question again. Ibrahim, can you listen to me? Ibrahim, are you still there? I think there's some technical problem. We maybe have lost the connection with Mr. Ibrahim. So we'll try to reply these questions again and we'll send it to you. I have this email with me now. Here I would like to thank Mr. Ibrahim for a very comprehensive presentation and very interesting presentation. I hope you would have benefited with this. In the end, I would also like to inform you all that we have next presentation. Oh, he's back. Ibrahim, we cannot listen you. We cannot hear you. Still we cannot hear you. So
I lost my connection. Can you hear me?
Yes, now I can hear you.
Aha. So I think there are many questions now. There's one on the, thank you for the presentation. The person is asking me, may I ask, among all the perspective of DFX, when applying them into exact project, say you're interested, is there any weighting or priority consideration? Oh, okay. Well, I think someone asked this question regarding whether there's a priority. It was very difficult to get access to detailed granular information, so I couldn't get information regarding that. But in my opinion, the choice of method depends on the objective of the project. If your aim is to get quality and time, then you should be targeting a specific method. So the priority depends on the objective of the project. And I think it is very, very useful to consider that, because you cannot just choose anything unless you are very sure that it's going to add up to the project. So that's my opinion. So is that all?
There's another question.
Okay, read for me.
Okay, how it is possible to integrate design for excellence on all sort of project, whether it is small or big one?
Okay. So design for excellence,
we don't do it manually because the iterations are too many. Not too many, but you need to be able to do a lot of things. And so for that, there is the need for you to use software tools. And I encourage that on all sorts of projects, whether small or big, you have to identify the best tools in the market, even if they are commercial, for design for excellence and use. Definitely, unless you are part of the design team, or maybe you are part of the project, you may not be privy to design for excellence. But it's very, very useful for you to know that design for excellence is a powerful concept and it's applicable to small or big projects, and it can be applied using software tools. I hope I've answered the question.
I think so. Thank you very much, Ibrahim. Now we, with this reply to the answer to the question, we complete this workshop. Thank you very much for your participation, your presentation, and it was a very comprehensive presentation. And here I'd also like to announce that our next workshop number 11 is scheduled on 11th June. So you are most welcome to join. I will send the link again. And last thing, that I will also send you the feedback survey link. You all are encouraged to please provide us your feedback so that we can further improve our presentation and workshop. Thank you very much once again, and have a nice weekend. Thank you.